Fuji Corporation became Japan's first company to use final disposal station sites to develop large tracts of excellent agricultural land on safe and solid ground, formed by employing a set of ground restoration systems that consist of its many patented, proprietary technologies, and utilizing the Fuji-style laid earth consolidation method and the Fuji-style rainwater blocking and management method as its two major technical pillars. Creation of agricultural land using the sites from final disposal stations. Plate-bearing tests were conducted on each layer of earth molded and consolidated to create a foundation to support agricultural land. These tests confirmed that the consolidated earth has a supportive power similar to that of bedrock at 2,800 kilonewtons per square meter at all locations. Permeability tests carried out in much the same way for each layer also confirm that the earth does not allow water to permeate into it regardless of the location. The upper section of agricultural land of the disposal station is completely separated and isolated from the lower foundation of consolidated earth by employing the Fuji-style direct wall hybrid agricultural land structure method. This method is a patented proprietary technology applied to utilize these vacant lots. 20 mm thick protective mats are laid after adjusting the final level of the Fuji-style restored ground upper capping, which constitutes the uppermost part of the final disposal station, and finished at the planned pitch by laying down pulverized rock. Rainwater is completely shielded by laying a 1.5 mm thick water shielding sheet on top and welding their edges to the water shielding work along the circumference. 20 mm thick protective mats are then laid to complete the surface capping process and completely separate the upper and lower facilities. The height of these facilities is adjusted by covering the surface capping work with a 50 centimeter final layer of earth. In order to drain rainwater, double-pressed, perforated pipes with a diameter of 100 millimeters are laid as the underground drainage line, and a 50 centimeter thick layer of earth is laid on top and connected to a water gathering basin to form the foundation of agricultural land. Rainwater is collected from all over the agricultural land by installing double-pressed, perforated pipes with a diameter of 75 millimeters, which branch out from the main line. A 70 centimeter thick layer of aseptic volcanic ash, whose particle size is adjusted to make it suitable for agricultural land, is next laid. Management roads are also developed as the upper underground drainage work with double-pressed 200 millimeter perforated pipes and connected to the water gathering basin. Rainwater gathered by the upper and lower underground drainage is conveyed to the final basin. Usually it is released directly to the external waterway, but by switching an electric gate installed in the final basin, it can be diverted into an underground storage pit with a capacity of 2,000 cubic meters. In this way, these facilities allow localized torrential rainpours to be reused for irrigation. Fuji Corporation has also introduced an inverter-run automatic feed pump unit with two 10 cubic meter water tanks and a lifting height of 48.4 meters, which is capable of discharging 1,707 liters of water per minute. This is one of Japan's most prominent dedicated large-scale irrigation systems. Since water is supplied from the neighboring deep irrigation wells, impurities such as sand are removed by installing semi-automated metal filters with internal cleaning functions. Highly corrosion-resistant stainless products are used for the feed pump and piping to prolong their life. Flow control valves with decompression functions freely adjust the volume and pressure of water sent to cultivated land, making irrigation management easy. The arrangement of pieces of terminal equipment such as sprinklers and irrigation tubes, which are capable of irrigating the entire cultivated land simultaneously, can also be flexibly changed as needed. This shows the process of using aseptic volcanic ash to create soil most suitable for the production of vegetables. Organic fertilizers are sprinkled at planned densities and uniformly mixed with whole soil using a large tractor. As the first test, wheat is cultivated to confirm how effective the fertilizers are, whether they are uniformly mixed with the soil, and how much soil flows out of the surface. Reaped wheat is later mixed with the soil as a fine-quality organic fertilizer. This soil development process is repeated, and the cultivation of vegetables for shipment begins several years later. Establishment of the new Fuji Site Visitor Center. On October 1st, 2014, we changed the name of the former final disposal station we owned to the Fuji Site Visitor Center in a move to retain it as our business model and open it up for inspection by a wide range of visitors. In this facility, the rebuilt equipment and machines, which were made using our own patents when the disposal station was installed and were put to actual use there, are now on display. The many ideas and patented technologies that were put to practical use are also available to the public in the form of panel presentations. The former basin to gather and internally hold water and the underground tank to store the water have been completely renovated using FRP waterproofing when the facility was discontinued. The former water treatment facilities have also undergone complete overhaul and are now still operable. Video cameras are installed at these important points to allow constant monitoring at the office through a large monitor. Live monitoring cameras in the former facilities are also used to monitor and manage the agricultural land. Since establishment of the final disposal station and the later utilization of the site for agriculture, we received many certificates of appreciation from the district government, neighboring districts, and other organizations for our environmental protection technologies. Our serious attitude toward business was also given high marks of approval. We are monitoring the facility to confirm whether water is held there. We are also monitoring groundwater in neighboring areas and facility rainwater drainage by checking the 46 environmental standards for groundwater contamination 4 times a year. Furthermore, as shown in the table, the concentration of radiation and radiation levels in the space of the facility are monitored monthly. When the disposal station was in operation, we made absolutely sure that the quality of recycled products was properly managed and that the environment around the station was protected. In the future, when the site is used for agricultural land, we will continue to maintain the current facilities appropriately and confirm whether the areas around the facilities are protected. On October 30th, 2014, officials from the Environmental Division of the Nagano Prefectural Government Saku Regional Office monitored the site, the first monitoring after the disposal station was phased out. On November 4th, 2014, the Nagano Prefectural Government Research Institute for Environmental Protection also monitored the site. Reinforced concrete circumferential vertical walls will be checked to confirm whether there are hairline cracks and whether the water repellents are still functioning. Appropriate maintenance work will continue to ensure the performance of the walls. Research and development of new environmental protection technologies. On the agricultural land created by the disposal station, introduced earlier, we are working with the National Agricultural and Food Research Organization's Agricultural Research Center to research new technologies at the Fuji Site Visitor Center, including technology to create farming soil suitable for agricultural production by using aseptic volcanic ash. As part of our research into technology to control the leaching of hazardous substances, we verified the effects of hazardous substance leaching by conducting leaching tests using samples molded by applying 25-ton pressure to cement mixed fly ash, which has a concentration of hazardous substances 100 times that of the standard for landfills, and placing them in environments ranging from 40 degrees Celsius to 40 degrees below zero at the Fuji-style extreme environment test room for specified periods of time. In our concrete surface finishing deterioration tests, several groups of 3 concrete samples are exposed to the natural environment for monitoring. One sample is prepared by applying FRP treatment to the surface. A second sample is prepared by treating it with water repellent. And a third is subjected to no treatment whatsoever. These tests are concerned with maintaining the quality of the concrete. Changes in the surface temperature of each sample are observed over long periods of time, and one group of samples is destroyed in each specific period to confirm their compressive strength, flexural strength, and degree of permeation. In this way, we can determine how effective the protective materials are in delaying deterioration of the concrete. We are working to devise technology for treating and disposing of mercury-containing waste as part of our efforts to create intangible assets, and to design structures to install final disposal stations dedicated to treating mercury as part of our efforts to create tangible assets. As described above, in order to ensure the safety and security of society, we will continue to research and develop new environmental protection technologies, making the most of our many advanced technologies and data that we have accumulated from past work operations.